So in this lesson series, we're going to provide an introduction to fluid mechanics. So, what is fluid mechanics? Well, fluid mechanics is a study of how fluids, which include both liquids and gases. This is a common misconception. When people hear fluids, they always think liquids, but often do not think gases. But fluid mechanics is a study of how fluids behave under various conditions, including at rest and in motion, and their interactions with forces and surfaces. So again, we're talking about fluid mechanics, which encompasses two other terms you very well may have heard before, which include fluid statics and fluid dynamics. So fluid statics, as its name suggests, studies fluids at rest, static scenarios. There's no change going on in the system. And that's compared to fluid dynamics, which studies fluids in motion, which is typically far more complex. So why do we care about fluid mechanics in the first place? Why is it important to mechanical engineering? Well, fluid mechanics is one of the most notoriously challenging and notoriously fascinating subjects in all of mechanical engineering. There's so much that you can do that, in fact, many of our most important modern devices use fluid mechanics in some critical way. So for example, we have something like system design, which is a fairly broad term, but this is aimed to encompass things like pumps and turbines and heat exchangers, fundamental machines that are used in all sorts of everything from refrigerators to oil and gas pipelines. Then we have force transmission. So namely, this includes hydraulic and pneumatic systems, which we'll talk more about in this lesson series. Then we have energy and efficiency. So for example, if we are talking about an aircraft which relies on fluid dynamics, remember fluids include both liquids and gases, well, it relies on a sophisticated aerodynamical understanding of how air surrounds and goes over the wing in order to get lift. So the more efficient that this can be understood and implemented into an aircraft, well, the more efficient and the more energy efficient that aircraft will be. And then lastly, we have things like safety and stability. So things like dams, large storage tanks, and large tanker ships all rely on a sophisticated understanding of fluid mechanics in order to make sure that everything goes according to plan. There are no potentially catastrophic engineering mistakes. So now let's talk about some key concepts in fluid mechanics that will be helpful for the remainder of our study. So I've already talked about this briefly, but the behavior of fluids is notoriously complex as they flow and deform continuously under applied forces. So let's think about that for a moment. Again, let's start by imagining a solid object. The atoms in that solid object are not moving. They're vibrating, but they are not actually moving from place to place. This is unlike a liquid, which is composed of billions and billions of molecules, which are each moving independently. They're not fixed in place. There's motion of the fluid through motion of the many molecules that comprise it. So for this reason, it can be very difficult to model fluids as well as we're able to model solids. So fluids are described by properties like density, viscosity, and temperature, which we'll talk about in more detail again through the remainder of the videos. And they have interactions with forces. So here's three of those key forces. We have pressure, where fluids exert a force per unit area. So the larger the force and the smaller the area, the greater the pressure. Then we have the buoyancy. So buoyancy is the upward force that's exerted by fluids on submerged objects. So this is why some objects will either be suspended in water or they will float in water rather than always sinking down. And again, we'll talk more about that just shortly. And then lastly, we have the drag force or the friction force. And this is a type of internal resistance within a fluid that slows the motion and dissipates energy. So when you're talking and you're studying fluid mechanics, drag is a very important concept that will come up again and again. And again, we are interested in fluid mechanics because it is so important to mechanical engineering, and it has many engineering applications. So one example is the hydraulic systems that we already mentioned before, which use fluid pressure to transmit and amplify force. Then we have aerodynamics, which is a whole field of study in and of itself, but aerodynamics relies heavily on fluid mechanics. And again, we have that example of an airplane. And then lastly, we have something like piping networks. So whether this is at a chemical manufacturing facility or an oil and gas operation, whatever it might be, piping networks play an enormous role in the way today's world is built and runs today. So being able to build efficient piping networks that are able to efficiently transport large volumes across great distances is incredibly important for allowing these processes to happen.